Greetings and welcome to Lesson 5.5, Similar Figures. In math, here's what we mean about similar figures. When two objects, like two triangles, two squares, two rectangles, have the same shape, that's the most important part, same shape, but they are different sizes, we say that they are similar. And if figures are similar, then the corresponding sides will be proportional. So let's take a look at two similar triangles. As we see, they look very similar. They're both very pointy at one end. The corners look just the same, but one's larger than the other. So they're different sizes, but they're similarly shaped. When we talk about the corresponding sides being proportional, that means there is a relationship from the side of an A with D, B with E, C with F. They are proportional. And if the proportion between all three sides are the same, then we can say the ratio, side A to D, side B corresponds to E, so there's a ratio of B to E. And side C corresponds to side F, so there is this ratio of C to F. Because the corresponding sides are proportional, that means that they are all equal to one another. So A over D will equal B over C, E, and C over F. So how does this knowledge help us? Let's say we have two triangles are similar, and we don't know one of the sides. So in the larger triangle, the three sides are x, 24, and 28. In the smaller triangle, who is similar to the big one, the sides are 5, 6, and 7. Because they are similarly shaped, we have a correlation between each of the sides. So 28 and 7 have a correlation. 24 and 6 have a correlation, as well as x and 5. Therefore, x over 5 equals 24 over 6 equals 28 over 7. Now here's the nice thing. Sometimes we have we do have two known ratios. One, we're not too sure. Now we know how to solve ratios by multiplying the extremes and the means. But here's the nice thing. We have a choice here. We can either do the extremes of x and 6 and the means of 5 and 24, or we can select x and 7 and 5 and 28. So it's up to you which math you want to do, but both are very valid to work out what x is. Since we can solve either one, I'll go ahead and work them both out. So let's see. X over 5 equals 24 over 6. We're going to multiply our extremes. X times 6 will equal our means, the product of our means, 5 times 24. X times 6 is 6x. 5 times 24, well, 24 times 5, 20, carry the 2, is 120. Now we need to divide by 6, and x will equal 20. That was one of our choices, is to select the x5 combination, x5 ratio, I should say, and the 24:6 ratio. Or we can work out the other way, is to say the extremes now are x and 7, so x times 7 will equal 5 times 28. Well, x times 7 is 7x. and 5 times 28, and 5, that's 40, 140. And now we want to divide each side by 7. X equals 20. So you see, either way, we can work out what the dimension of that missing side is. Other similar figures could be rectangles. So in this case, I have 2 rectangles. And this could be, maybe it's a picture and you need to resize a picture. So let's say you're on your computer and you want to resize a picture. If it is a picture of a person, if you only widen it, then they're going to look really fat. Their faces are going to widen, their bodies are going to widen, everything's going to widen. If you just stretch it tall, then they're going to look really super tall, but they're not going to be proportional. So we want pictures to be proportional to what they started off with. So if we have a small picture, we want to make it larger. It needs to both grow width-wise as well as height-wise. Alright, so let's say we have this rectangle in the dimensions of its height is 120 and its width is 160. And the large, we want to expand our small rectangle. We're not too sure what the height will need to be, but we know the width has to fit into a spot that's 320. 320 centimeters, 320 inches, whatever it is, it's 320. So how do we set up this problem? Well, we have similar figures. Therefore we have a relationship between the height of the large one and the height of the small one. Likewise, the width of the small one and the width of the large one and the width of the small one. So we can set it up as h is to 120, as 320 is to 160. Now the only problem you might get into is if you confuse who goes with what. You want to keep, if your large square or rectangle or triangle, if that information is on the top, then in your second ratio, it better be on the top. The only way that you can kind of get in trouble with these is if you flip it somewhere, where this is the large information, small information, large information, small information. Now we're going to do our multiply our extremes, multiply our means. We get 160h equals 320 times 120. So 168 equals 38,400. Divide each side by 160, and therefore the height that we should have is 240. Alright, so that's actually it for this video. Let's see if we can come up with one more example. Alright, so let's see, we have 2 triangles below are similar. Let's find the missing side, the missing dimension. Alright, so if these are similar triangles, we can set it up as ratios. Each side is a ratio of the other side. So the corresponding sides, and it doesn't matter which triangle's information you set as your numerator and which triangle's information you set as the denominator, but once you do that, just remain consistent. Right? So I'm going to go ahead and put the leftmost triangle as my numerators and my right triangle as my denominators. So 3 is to x, 3 is to x, that will equal 7 is to 21, and 9 is to 27. Now it's my choice as to which combination of 2 of these variable values that I want to use. Do I want to use the 3 over x and 7 over 21, or do I want to use the 9 over 27? I'm going to go ahead and do the 3 over x and 7 over 21. Alright, so 3 over x equals 7 over 21. Okay. Extremes and means. 3 times 21 will equal x times 7. 3 times 21 is 63 equals 7x. Let's divide each side by 7. Therefore, x will equal 9. So this side must equal 9. There also is another kind of a second way of looking at this. 3 and 9 are equivalent to one another, right? 3 times what gets you 9? Well, 3. 7 times 3 better get you 21, and 9 times 3 better get 27. So that ratio of 3 to every side is the consistent part of this process. Okay? So let's try it again. This time with rectangles. Right? Again, we want to make sure that the width goes along with the width and the height goes along with the height. So they are proportional. So the width will go along with the width, 540. The height, and I'm staying with the larger one, will be the numerator. So 612 over 306. Now before I do some math, maybe I can reduce a little bit. Okay? 306 does go into 612, therefore I can reduce it. 306 goes into 306 once. 306 goes into 612 twice. So my new problem is W over 540 equals 2 over 1. That is definitely a little bit simpler problem. All right, now I'm going to do the extremes and means. W times 1 is W times 1, and 540 times 2 are our means. Okay. That leaves W equals 1080. Right? 540 times 2 is 1080. So there is our answer. It's okay to do this. It's okay to reduce. Okay? It's okay to reduce before you do. It's the reduce now versus reduce later. Okay. Now, let's do something a little bit different. Let's draw a triangle similar to triangle ABC. If AC is proportional to DF, we want to make E some point up here, because it's got to look the same, that holds the same proportion. Okay, so let's check it out. The length of AC, so AC, the length is 2. DF is 1, 2, 3, 4. BC is 1, 2, 3, 4. Okay, so we have a 2 and a 4, and a 4 and an I don't know and an I don't know. So therefore, EF is our unknown. Okay. AC is to DF, so 2 is to 4, as BC is to I don't know. Okay. And here we can reduce, but I'm going to go ahead, the numbers are small enough to where I can multiply these numbers. So I'm going to go ahead and do our product of our extremes and products of our means. 2 times x is 2x. 4 times 4. So 2x equals 16. Going to divide by 2. Therefore, x must equal 8. Therefore, EF must equal 8. Okay. All right. So 1, 2, 3, 4, 5, 6, 7, 8. So that means E must be way up there. Right? And then it's just connecting the dots as best as I can without a straight edge. All right, let's take an application problem. The entire length of a violin is 24 inches, while the body's length is 15 inches. Now, I can't draw a violin for the life of me, so I'm just going to say the whole length of the violin is 24 inches. And if you're familiar with the shape of a violin, it has a body, something, I know it's kind of like that, and it has this neck, like that, and it has strings on it, and you use a bow to play it. So the whole entire length of the violin is 24 inches. The body's length is 15 inches. Now, a double bass is a similar shape as a violin, but it's just really big. Its body's length, if its entire length, is 74 inches. The whole thing is 74. We want to know, remember the body's like this, we want to know what the body's length is. It doesn't hurt to draw yourself some pictures so you can figure out what's happening. Alright, so if we are working with similar figures, which we are, the body of the violin will be a similar ratio as the body of the double bass. So the body, the length, sorry about that, the whole length, the length of the violin will have the same proportion as the length, TH, of the bass. Likewise, the body of the violin will have the same proportion as the body of the bass. And we just got to put in the numbers. The length of the violin is 24 inches. The length of the bass is 74 inches. The body of the violin is 15. The body of the bass is, we don't know. Okay. Is there anything here that we can reduce? Could. And I think I will, because I don't like working with this big number of 74, so I think I will reduce. Let's see. 2 goes into 24 12 times. 2 goes into 74 37 times. I'm willing to work with those numbers a little bit better. Okay, 12 times x is 12x. 37, times 15. I got to figure out what 37 times 15 is. 5 times 7 is 35, carry the 3, 5 times 3 is 15, 6, 7, 18, and then 1 times 37 is 37. That gives me 555. Okay, 555. Now, we got to figure out, let's divide by 12. And I'm not going to do that off to the side. I'll let you work on that problem yourself. But x equals 46.25, okay, inches. So we can expect the body of the bass to be 46.25 inches. All right. And that's it for this lecture. Until next time, be seeing you.